Welcome to our comprehensive guide on brick and stone masonry, essential components in building materials and construction technology. In this video, we'll explore the key terms, types, and techniques that form the backbone of durable structures. Whether you're a student, aspiring builder, or simply curious about how buildings stand the test of time, this journey will clarify the basics and intricacies of masonry. We'll start by defining fundamental terms, then move through various brick bonds, reinforced masonry, and finally, the fascinating world of stone masonry. Let's lay the foundation for your understanding, brick by brick and stone by stone. Before diving into construction techniques, it's crucial to understand the language of brick masonry. Terms like stretcher, header, arrêtés, bed, and bed joint are foundational. A stretcher is a brick laid with its length parallel to the wall's face, while a header is laid with its width parallel. Arrêtés are the sharp edges formed at the intersection of brick surfaces, and the bed is the brick's lower surface when laid flat. The bed joint is the horizontal mortar layer supporting the bricks. Mastering these terms ensures clear communication and precision on the job site. Pins and lap are vital for strong, stable walls. Pins refer to the vertical joints separating bricks, and for a solid bond, these should align vertically in alternate courses. Lap is the horizontal distance between vertical joints in successive courses, ideally 1/4 the brick's length. These details might seem minor, but they are crucial for the wall's strength and longevity. Properly aligned pins and correct lap distribution prevent cracks and ensure the wall can bear loads efficiently, making them essential concepts for any masonry project. Closers are pieces of brick used to close up the bond at the end of brick courses, preventing vertical alignment of joints in successive layers. There are several types: queen closer, king closer, beveled closer, and mitred closer. A queen closer is made by cutting a brick lengthwise, often placed near the coin header for proper lap. King closers are cut to provide both header and stretcher faces, useful near openings. Beveled and mitred closers are shaped for special corners and junctions. These variations help maintain the wall's integrity and appearance. Let's look closer at the different types of closers. Queen closers are typically placed next to coin headers to achieve the necessary lap. King closers, with their unique triangular cut, are ideal near door and window openings. Beveled closers have one face as a closer and the other as a header, suitable for splayed brickwork. Mitred closers, cut at an angle, are perfect for corners and junctions. Each type serves a specific purpose, ensuring the wall's joints are staggered and the structure remains robust. Brick bats are pieces of brick, such as half or three-quarter bats, used to fill gaps or adjust the length of a course. Beveled bats are shaped for specific needs. Bullnose bricks, on the other hand, have a rounded angle and are used for rounded corners or coins, where the wall changes direction. These specialized bricks not only enhance the structure's strength, but also contribute to its aesthetic appeal, especially in visible or decorative areas of a building. Cownos bricks feature a double bullnose on one end, perfect for creating smooth, rounded edges at corners. Squint coin bricks are specially cut or molded to form angles other than 90 degrees, allowing for creative architectural designs and non-standard wall junctions. These bricks are essential for achieving unique shapes and ensuring the continuity of the wall's bond, especially in complex layouts or decorative features. Frog is a depression on a brick's face, typically 10 to 20 m deep, providing a key for mortar and improving the bond. Racking back refers to the step termination of a wall, while toothing involves projecting alternate courses at the wall's end to facilitate future extensions. These features are practical solutions for construction flexibility, allowing for strong mortar adhesion and easy continuation of work as building needs evolve. The English bond is widely regarded as the strongest brick bond. It alternates courses of stretchers and headers, with queen closers placed next to coin headers for proper lap. Each header is centrally supported over a stretcher, and the joints remain straight, ensuring stability. This bond is preferred for its strength, especially in load-bearing walls, and is characterized by its regular, robust appearance. Understanding the English bond is fundamental for anyone involved in masonry construction. Key features of the English bond include alternating courses of stretchers and headers, with queen closers placed next to coin headers. The joints are straight, and continuous vertical joints are avoided except at certain ends. The header course has more mortar joints than the stretcher course, so care is taken to keep them thin. For thicker walls, only the face courses use stretchers or headers, while the interior is filled with headers. This bond ensures both strength and a neat, organized appearance. Flemish bond offers a visually appealing alternative to the English bond. In this bond, headers and stretchers alternate within each course, creating a distinctive checkerboard pattern. There are two main types: double Flemish bond, where the pattern appears on both faces of the wall, and single Flemish bond, which combines Flemish on the face with English bond backing. While not as strong as the English bond, The Flemish bond is favored for its decorative effect, especially in visible wall sections. Double Flemish bond features alternating headers and stretchers on both the front and back elevations, creating a uniform look. Single Flemish bond uses the Flemish pattern on the face, with English bond for the backing and filling, combining strength and aesthetics. These bonds require careful placement of bats and closers, especially in walls of odd thickness. While the Flemish bond looks attractive, it's important to note that it's not as strong as the English bond due to the higher number of stretchers. And strength is paramount. Reinforced brick masonry is employed. This technique incorporates steel or iron reinforcement within the brickwork, enhancing its ability to resist tensile and shear stresses. Reinforced brickwork is ideal for structures on uneven soil, retaining walls, beams over openings, and seismic areas. The reinforcement, usually in the form of bars or mesh, is embedded in dense cement mortar, making the construction durable, fireproof, and economical. This method allows for thinner walls without compromising strength. Reinforced brickwork finds use in various structural elements. In walls, reinforcement is provided horizontally or vertically using bars or mesh, often at every third or fourth course. For piers, steel plates and bars are anchored into the foundation. Brick lintels use steel bars placed in gaps between bricks, while slabs are constructed with reinforcement embedded in mortar. This approach not only increases strength, but also allows for creative architectural solutions, especially in areas prone to heavy loads or seismic activity. Stone masonry relies on various joint types to ensure stability and durability. Common joints include the butt or square joint, where flat surfaces are placed together, and the rebated or lap joint, which prevents stone movement. Tongued and groove joints, also called joggle joints, involve projections and recesses to prevent sliding. Tabled joints use joggles to resist lateral movement, making them suitable for structures facing heavy pressure, such as sea walls. Each joint type serves a specific structural purpose. Other important stone joints include the saddled or water joint, designed to divert water away from vulnerable areas, and the rusticated joint, where stone edges are sunk below the general level for visual effect. Plug joints use dovetail-shaped mortises filled with molten lead or cement grout, while dowel joints insert hard stone or metal dowels for added stability. Cramp joints use metal cramps to connect stones, especially in columns or where extra strength is needed. These joints enhance both function and appearance. Coursed rubble masonry arranges stones in courses, with each course containing stones of similar height. There are three sorts. I-sort uses stones in courses of the same height. II-sort allows different stone heights and course heights, and III-sort uses even more variation. This type of masonry is common in public and residential buildings, offering a balance between strength and cost. The careful sorting and laying of stones ensure a stable and visually pleasing wall. Coursed rubble masonry uses stones as they come from the quarry, with little dressing. Courses are irregular, and larger stones are laid first, with gaps filled by smaller pieces. Random rubble masonry arranges stones of irregular sizes and shapes for a natural look. If face stones are chisel-dressed and joints are thin, it's called random rubble I-sort. If hammer-dressed with thicker joints, it's II-sort. These types are cost-effective and often used for compound walls and simple structures. Dry rubble masonry is similar to coursed rubble, but uses no mortar, relying on skillful placement for stability. Polygonal rubble masonry features stones dressed into irregular polygonal shapes, creating a unique appearance but requiring high skill. Flint rubble masonry uses hard, brittle flint stones, often with lacing courses of bricks or tiles for added strength. Each type serves specific needs, from cost-saving dry walls to decorative polygonal and region-specific flint masonry. Ashlar masonry uses square or rectangular stone blocks, offering a refined look. Types include ashlar fine masonry with finely chisel-dressed faces and thin joints for a smooth finish. Ashlar rough tooled, where only the beds and sides are smooth and the face is rough. Ashlar rock or quarry faced, with a chisel strip around the edge and a rough central face. And ashlar chamfered, where the edge strip is beveled for a grooved appearance. Each type balances cost, appearance, and structural needs. Ashlar blocking course masonry bridges the gap between rubble and ashlar types. The stone faces are generally hammer-dressed, and the courses vary in depth. Mortar joints are kept thin, and the result is a wall that combines the strength and appearance of ashlar with the economy of rubble masonry. This type is often chosen for projects where both durability and cost-effectiveness are important, providing a neat yet robust finish suitable for many building applications.